Hey, in this tutorial I'm going to show you how to create this minimal yet amazing looking slider. Before we start, all the work we are going to do is going to be based on the WebGL library Pixi.js. Therefore, a basic knowledge of Pixi is required to fully understand every step we are going to do. That said, if you haven't heard of the library or never had the chance to use it, don't worry because I have already created a tutorial which will help you to get a good grasp of the fundamentals which we are going to apply in this video. So check out the tutorial by clicking on the link at the top right corner of this video, or you can find it in the description below. First and foremost, we need to have a handful of images. If you don't know where to find some, Unsplash is definitely the best place where you can find high quality images for free. Now let's get started by creating the index file, then create the label and the slider controls. That done, we need to type some CSS code to place the HTML elements we've just created. So this is going to remove any unwanted default paddings and margins. The next step we need to do is to make the controls container take the entire viewport and then position its children elements inside of it. Nothing complicated. I always use the calc function to set the font size, which is a very good practice for responsiveness since we are bounding the font size to the size of the viewport. Now we are going to create that thin text background using the before pseudo element. Then we need to set some common properties for the two slider controllers. So first we need to remove the default style of the buttons, then set inherit to the font family property so it will inherit its value from the parent element. And then we need to position each controller to the middle of the right and left sides of the slider. Now the fun part. First we need to either install Pixi.js using npm or we can grab a CDN link. In this case I'm going for the second option, but bear in mind if you want to get the latest version of Pixi, don't copy it from the main page. Instead go to the releases section and grab a link from there. That done, let's create a JS file and make an instance of the Pixi application class and see if we are ready for the next steps. And there we go, now we need to append the canvas to the DOM. As you can see, the canvas appeared, but notice the additional unwanted scrolling space horizontally and vertically. To get rid of it, we need to add some CSS style to the canvas. So back to CSS, we need to set the width and height of the canvas element to 100% and then center it using the position absolute and the negative 50% translation trick. The scrolling space got removed, but we lost the slider controls because when we set the canvas position to absolute, it covered them, so we need to set a higher z-index value to the controls container to bring it to the top. Now it's time to load the images. To do that, we need to create a loader and then put the paths of the images to an array set as argument to the add method. Then we need to create a function that will be called once the images are loaded. This function will hold all the logic needed to make the slider work. That said, we need to create 4 sprites out of the 4 images, then add them to a container. Notice that I added the sprites in a backward order because I want image 1 to be on top, then image 2, and so on. So, added to the stage, the images appear, yet there is something wrong here we need to fix. To see it, let's try to resize the window. As you can see, by resizing the window, we are stretching the images, which affects in a bad way how they look. Instead, what we want to do is to make the canvas maintain the aspect ratio of the images. To do that, we need to add one CSS property called object_fit to the canvas element and set its value to cover. Now we are basically compromising some parts of the images in order to keep them looking good and not excessively stretched. Another thing to mention is that since I have already cropped the images to make them match the size of the canvas, they look centered by default. However, if I had to put them in their original size, I mean way bigger than the canvas size, the left corner of each image will match the left corner of the canvas, but the rest will not, which means the image will not be centered. And to fix that, we simply need to center the images manually. This needs to be done to all the images unless you don't want to center them. I didn't do it in the video, but you'll probably find it in the demo code. Actually, you'll find me using a function to center each image instead of repeating the process for every single one of them. So now that we have the canvas and the images ready, let's implement the logic of the right slider controller. First, let's put the label and the button into variables, then add the event listener to the button. The next step we need to do is to create a counter and initialize it to 1. This counter will serve as an index that tells which country name and image the slider should show. So every time we push the right button, the counter needs to be incremented. Then I'll use a switch statement to update the label and the background images later on. Everything is looking good, but we still need to add a condition to prevent the button from incrementing the counter once it reaches 4, since our slider is composed of 4 slides only. The next step we need to do is to install or add a CDN link to an additional set of Pixi filters, which includes a specific filter that is needed to achieve the ripple effect. Now that we included the filters, we need to create an instance of the ShockwaveFilter class, which constructor method takes 3 arguments. The first one is an array that has 2 numbers which represent the coordinates of the center of the ripple. We want the ripple to start from the center of the canvas, so we simply need to set half of the width and half of the height of the canvas as the x and y of the wave's center. The second argument of the constructor is an options object. We'll get into it in just a second. And the third argument is time, which represents the state of the ripple at a certain moment. This is the most important piece of the filter, since we are going to animate the ripple based on this value. So back to the options object, it has an amplitude property. I'll set its value to 300, which is the default value. Then we have the wavelength property, which value is set to 160 by default. We have also the speed property. I'll set its value to 700, the default value is 500. There is also brightness. We'll leave its value as it is, and the same thing with the radius. That done, now we need to add the filter to the container, and let's see what we got. As you can see, we got a ripple at a very early stage, so if we increase the time, we get the ripple in a later state. So since we don't want the ripple to appear on the image unless we hit one of the slider controllers, let's set the wavelength value to 0. Now to increase the time value which will create the wave movement effect, we are going to use the ticker method. In other words, every time we push the right or left button, a handler that increases the time will be added to the ticker. If we test this out, the ripple will not appear, of course, because it has the wavelength equal to 0, so let's change that. The next thing we need to do is to decrease the alpha, aka opacity of the current image when the button is pushed, so we can see the next image. Let's do the same thing, but now from the second slide to the third. The effect doesn't work this time, only the alpha is decreased, but the ripple doesn't appear. To explain what happens here, notice that we are increasing the value of the time property at the call of the first transition, which means by the time we try to go from the second slide to the third, the time property has a value that makes the ripple way outside of the image. So what we need to do to prevent that from happening is to reinitialize the time property every time it reaches a certain value. In other words, we need to set an end to the animation, after which everything should go back to the initial state. I made some tests and the sweet spot I found to end the animation is when time is equal to 2, but I still highly recommend you making this value dynamic, which means the calculation of the value must be based on the width of the viewport if you intend to use this in a real-world project, because 2 might feel quite a bit long for smaller screens. And the next step we need to do is to remove the entire handler from the ticker to prevent the collision that would occur when the ticker is running more than one handler at the same time. So now, after finishing the transition, notice that the ripple returned back to the initial state, yet it still appears. That's because we didn't reset the wavelength to 0. And now we need to replicate this for the rest of the cases. Another problem we have is when you click another time on the button before the end of the transition, the animation gets faster and is thereby ruined. To prevent that from happening, we need to create a variable that will serve as an indicator, which tells if the animation is completed so the next one could take place. So we are basically preventing the button from activating the transition from one slide to another unless the animation is ready. So initially the animation is ready, then once it takes place, wave ready needs to be set to false, and then reset to true only when the animation is finished. And there we go, problem solved. Before we move on to the next step, let's summarize what we did so far, because it's important to understand what we are going to do next. In a nutshell, we had 4 images stacked on top of each other, and we made it in a way that every time we click on the right slider controller, the image on top gets its opacity decreased to 0, which makes the image just underneath it appear, alongside the effect being applied to the entire container, of course. That being said, let's create a binding for the left button and add the same code we used for the right button and make the necessary edits. So here I just created another handler for the transition from the last slide to the second last one. Now if we test this out, the result is not exactly what we want, and the reason is simple. Going from the first slide to the last one, we dropped the alpha value of each image to 0, so when we tried to go back, the images had their alpha at 0, therefore invisible. To fix that, you may think that we need to reinitialize the opacity of the previous slide to 1. To see if that works, let's do that. And it didn't work. Why? You might be asking. Well, as I said earlier, the images are stacked on top of each other, and the order in which we added them makes the third image on top of the fourth. So no matter what alpha value the fourth image has, starting the third image with an alpha value equal to 1 will show it instantly, preventing us from seeing the fade out effect of the fourth image. Another solution you may want to try is to increase the alpha value of the third image while decreasing the alpha of the fourth image. Again, let's try to do that and see if that fixes the problem. Problem partially solved, and I said partially because as you've probably noticed, there is a sort of a gap between the appearance and disappearance of the two images. That gap is basically the time where both images' opacities are so low, so it's the background of the canvas that appeared during that period. So, after experimenting for a while, I got a working solution composed of 3 steps. First, each time we pass from one slide to another, we have to initialize the alpha value of the slide we are going to 1. The second thing we need to do is to make sure the next image is on top of all the other images by the end of the animation. The third and last step is to bring the current image back and set its opacity to 0. Enough with explanations, and let's transform the plan into code. So here we need to initialize the second image alpha with 0, then set its z-index property to 2. Bear in mind though that z-index will not work unless we set the sortable children property of the container to true. Then we need to make sure the z-index of the first image is less than the second image, so on in this case, and set its alpha value to 0. And then of course we need to apply the same thing to all the transitions. The code starts to look repetitive and verbose, but don't worry, we'll clean it up in a second. And there we go, the slider now works as intended. Now notice we are repeating the exact same things at the beginning of each transition. We are increasing the value of time, decreasing the alpha of the current image while increasing the alpha of the next image, setting the value of wave ready to false. A function to do all of that can help with reducing this big amount of code. Let's name it start animation and make it take 2 arguments, which are the only varying pieces of these repeatable chunks of code. That done, let's take the definition of the function to the bottom and use it in all of the 6 cases. The same thing is applicable to the code of the end of the animation. We are resetting the time and wavelength to 0. We are changing the z-index of the current and next images. We are setting wave ready to true and removing the current handler function from the ticker. That said, a function that takes the current image, the next image, and the transition sticker callback function as arguments would save us more than 20 lines of repetitive code. Make sure to like and subscribe, and I will see you in the next video.